Okay, so now let's get to the last or the second to last problem. I think we still have two more. This one now, you'll notice that the degree of the numerator is less than the degree of the denominator. So we have our degree of a to the x is 1. We have our degree of b to the x, because we have x plus 2 times x minus 1. That's really an x squared, so I can see that the highest degree is going to be 2. Now, what does that tell me? That gives me some information about the asymptote. So we go now to the asymptote. And for the vertical, you can see that we have two asymptotes. We have x equals -2 and x equals 5. Comes from that one by setting both of those equal to 0. And then we have our horizontal asymptote. And in this case, our horizontal asymptote is y equals 0. That's given when the denominator degree is bigger than the numerator degree, or vice versa, the numerator degree is less than the denominator degree. And then our oblique, well, there is none. Okay, finally, we go for our zeros. And so for our zeros, you see that 2x is in the numerator, so we're going to set 2x equal to 0. And of course, we're going to divide both sides by 2, so x equals 0. And then we're going to plug it back in, so y equals 2x over x plus 2, x minus 5. And if I put a 0 in there, I get 0 in the numerator. I get 2 times -5 in the denominator, which is 0 over -10. I didn't really have to do all those steps, but just 0. So that means it's going to cross at 0, 0. So we can kind of see that at 0, 0, we're going to be crossing the axes. So if we go back over now and we graph it, and notice some things here so we can see what's going on here. We're going to go ahead and graph this function. So it is f of x equals 2x divided by x plus 2, x minus 5. So we can see that function. So we can see what that function is doing. I'm going to temporarily turn it off. I'm going to come down here. I know that we have y equals 0 is one of them. So I'm going to go ahead and turn that into a dashed line. You can kind of see the dashed line there. And then on the other one, if we have we have 2. So we have 1 at x equals positive -2. We're going to go ahead and turn that into a dashed line. And then we have another one at x equals 5. We're going to turn that one into a dashed line as well. So when we turn both of those into dashed lines, we've got that. Now we're going to come up here, so you'll see what kind of my function is going to kind of look like. You kind of have a general idea. I'll go in a little bit just to kind of see it a little bit better. You can see my dashed line here, here, and here. We have 3 dashed lines. Now we turn on the function, and you can see what's happening. And you can see it goes through 0, 0 like it should. Okay, so that takes care of, I think, all of them, if I'm not mistaken. We're not on page 8 yet. Now we're on page 8. Okay, so here's another one. So this one actually deals with going through and in this particular case, actually factoring. So I have to factor the numerator. The reason why I wanted to bring this one up is because in the numerator, we have x plus 1 times x squared minus x minus 1x plus 1 squared, or plus 1. And I know that because this is a perfect cube. So there's a rule for a perfect cube, which is the one I just did. So x plus 2, x minus 2. Notice nothing cancels, so there is no open point on any of these things here. This can never be factored. I already know that can't be factored because that's the way a perfect cube works. Whatever that comes out to be, it will never be able to be factored. So now we can see some things, though. We look at the degree of the functions, and we can see, and notice we're going to have a lot of What can I think of them? I don't know why it's slipping my mind right now, but anyway, I'll think of it in a minute. So the degree of a of x is 3. Degree of b of x is 2. It's 1 greater. So we have, that's what the word I was looking for, asymptote. So we have, for our asymptotes, we have our vertical asymptotes. We can see that one is at x equals negative 2, and the other one's at x equals positive 2. So we know that much. We have a horizontal asymptote. Actually, never mind. We don't have a horizontal asymptote. And the reason why we don't have a horizontal asymptote is because the a of x is greater than b of x. But we do have an oblique because a of x is only 1. The degree is only 1 greater than the degree of b of x. And so in that particular case, we do have one. So we can figure out what that is by looking at the coefficients in front. Notice that the coefficient in front of x cubed is 1. The coefficient in front of x squared is also 1. So therefore, y equals 1. Okay, 1 over 1. So those are all the things that we have to go through and graph. And then we'll figure out the zeros here in a minute. But what I want to do first is I want to put in those asymptotes. So I'm gonna go ahead. I'm just gonna keep going on this. So we have one at, well, we'll do our function. So f of x is equal to, and we're gonna write the original one. So we have x cubed plus 1, and we're gonna be able to see all this stuff up here, which is gonna be really nice. X squared minus 4. I'm gonna temporarily turn that off. That doesn't really matter. Just forgot to press it. And then what we're going to do is we're going to put in all of our asymptotes. So we know that at y equals 1, we have 1. I'm going to change that to a dashed. We know that we have another one at x equals 2 and x equals negative 2. So we're going to go ahead and put those in. And notice that, yes, as we're taking all this time to do it, we are already predicting what this thing is going to look like, and we have a good general idea of what this function is going to do. Okay, so notice we have all these things here. So it's going to be some weird stuff, but it can't go over any of these dashed lines. So it's not going to be like that function that went kind of crazy and did some extra stuff. We also know that we have a point. Remember that this actually came up with x plus 1, so we have a 0. So we do have a 0. So our 0 is when x plus 1 equals 0. Now, where did I get that x plus 1? Right from there. This one we can't factor, so we're not going to have a value for that one. And so we have x plus 1 equals 0, so that means that x equals negative 1. So at x equals negative 1, it should cross. So it should cross right here at x equals negative 1. Okay, now, we don't know if that's negative 1, negative 1. That's what we're going to kind of find out now. We're going to plug it in. So remember, our f of x is equal to x cubed plus 1 all over. We have x squared minus 4. So we're going to plug in a negative 1 there. So we have negative 1 cubed plus 1 over negative 1 squared minus 4. And so that's going to give me negative 1 cubed is negative 1 plus 1 all over negative 1 squared is 1, 1 minus 4. So that's going to give me 0 over negative 3, which is going to be 0. So that means that at this point, x equals negative 1, y equals 0, we have a 0. So negative 1, 0. So what I'm going to do here, just to kind of prove all this stuff, to show you how it works, and you can actually plot a point at negative 1, 0, whoops, not negative 10, negative 1, 0. Notice how it plotted a point there for me, and I wanted to be able to see it. So I plotted it just to see it. Let's go ahead and look at our function, and boom. Okay, now we do have that horizontal asymptote. I want to make sure that I really check. Oh, that wasn't a horizontal asymptote. We had an oblique. Oh, I screwed this one up. So I missed the horizontal, the oblique. The oblique isn't, that's a That's a horizontal asymptote, not an oblique. Remember the horizontal asymptote, we have to divide it into it. So we have to divide x squared minus 4 into, so I made a mistake here, into x cubed plus 0x squared. Here we go. We're going to do this down here. So we have x squared minus 4 divided into x cubed plus 0x squared plus 0x plus 1. So that's really x cubed plus 1. Okay, so then we divide x cubed divided by x squared. That just gives me x. X times x squared is x cubed. X times negative 4 is negative 4x. So notice how I'm writing them underneath those different pieces there. We're going to subtract this one. We're going to add that one. So we change the signs of those two. So therefore, we have 0x squared, which isn't going to matter. We have a 4x there. So we're going to just bring down a 4x plus 1. In a sense, that's kind of our remainder. So we should have, since x squared can't go into 4x, and since we have nothing under the x squared term in here that we can't divide out, this will be our oblique asymptote. So that would be y equals x. I should have been more careful with that and made sure that I understood that. So this isn't true, y equals 1. We have it at y equals x. And there we go. And we can see that. Okay, and that's my oblique asymptote. Now you'll notice that part of the function does cross over, and I don't know where I got this one from. Where did I get that one from? Oh, x equals 8. What was I thinking? Okay, so x equals 2, so you can see that. So you'll notice that these two pieces do not cross the oblique. This one does, but this one stays within the vertical. Now this is a more complicated problem. Notice that even though I have this oblique asymptote, the oblique asymptote will show you that it's actually a mirror image of it on the other side. So we can kind of see that. Okay, but that's it. Some difficult problems. A lot of these I'm not going to test you on, but I just want you to be able to learn how to predict these things. And notice, don't worry about making a mistake. Once I graphed it, I realized that my oblique asymptote was wrong.